Welcome, everyone. Today is our last webinar of the self-learning phase. So thank you so much for joining live. And as usual, a very good morning to those of you who are joining us from Europe, and a very good afternoon to those of you joining us from Asia with us. And one of our speakers is actually joining from the United States of America, where it's 4 a.m. So please, let's support our speaker today, who is, made the effort to be there, to be here for us in such early morning. Just to remind you about some admin rules, please rename yourself with your first name, last name, and country so that we know when you are interacting, where you are connecting from, and who you are. And please kindly mute yourself so that there is no interference during the presentation of our speakers, so that it's not disturbing for them as well. And as you are listening to their presentations, if you have any questions, please feel free to put them in the chat box. And if you have any questions that you would like to ask, please make sure that they are very precise and they are very short, so that a lot of you can have, at least, most of you can have the opportunity to ask questions directly. And as usual, the webinar format will be, right now we're having the welcome sessions and a little bit of speaker introduction. And then our speakers will be presenting thematic content presentation. And then we'll have question and answer session. And then we'll tell you about what to expect for next phase. Today is a perfect Asia-Europe session because we have a speaker from Asia, Mr. Terence Tan, and we have a speaker from Europe, Dr. Aida Pretnar-Zagar. Dr. Aida, she's from the University of Ljubljana, from Slovenia. She's a researcher, and also she's involved in the initiative called Orange Mining that she will be talking about. And Mr. Terence Tan, he's a general manager at ED8 Maker, which an organization, an education technology organization based in Singapore, and he's currently based in North America, where he's connecting from. So I'll give the floor to them to introduce themselves, to introduce more about themselves. And now I give the floor to our first speaker, Dr. Aida Pretnar-Zagar, to talk about the examples of existing practical and effective artificial intelligence in education tools. Dr. Aida, the floor is yours.
Hello, everyone. My name is Aida Pretnar-Zagar, as Jyoti mentioned. I'm a researcher at the Faculty of Computer and Information Science at the University of Ljubljana, and at the same time at the Institute for Contemporary History. At both organizations, I focus on digital humanities and computational approaches in social sciences. And I'm also involved in orange data mining development. And this is something I will talk about today, and I will explain why this might be relevant to you. So in today's presentation, I will first introduce orange data mining software. What is it, why it's of relevance to educators, and how it works. Then I will talk about Pumice, which is a project that introduces AI to primary and secondary schools in Slovenia. We've been involved in this for the past year, so I think this will be of relevance to you as well. And in the end, I will showcase one such example of AI lesson focusing on distinction between Monet and Manet. So this will be an art history example. Okay, so orange data mining is an open source tool for data mining and machine learning. So this is a subsection of AI, data management and navigation. So machine learning, how to find patterns in the data and how to explain them. So this is what orange data mining does. This tool is not a like a black screen where you have to type in commands, but it's based on visual programming. This means that it consists of basic computational components. We call them widgets. Each component performs a step in data analysis. So it loads the data, it visualizes the data, it builds a machine learning model, and so on. So how you work with this software, it's very simple. You just stack these components in a workflow. And this is why we believe this software is fairly easy to use, because it has no coding, no programming. It's just connecting components together. And moreover, it's not just that it's customizable and easy, like visual. It also features interactive data exploration and interactive visualizations, which means that when you visualize the data, when you open a projection, you can explore it. You can click on specific data points. You can see what they mean. You can really dig deep into the data. And I will show this software later on, so you don't have to imagine it, but you will see how it works in reality. Now, why is this relevant for educators? First of all, Orange was developed with educators in mind. So it started, I think, back in 1996 by two of my bosses. And the main idea was to facilitate machine learning for non-experts, for non-programmers. At first, they used it to teach machine learning at the university level. And the goal was just to leverage intuition in how machine learning algorithms work. Hence, the reliance on visual programming. This is why this software is visual and interactive. So in the past few years, we really wanted to go from university to lower levels of education, so to secondary schools and to primary schools. And we really wanted to simplify this software so that really anyone can use it. Okay, so that's it for Orange Data Mining. I think it's best if I show you how it works later on. And here you have the website where you can download it. It's free of charge, so you can use it on your own computers at any time. Okay, oh, there you go. So I mentioned Pumice. Pumice is the Slovene pronunciation of this project. It means little cougars, hence the icon for the project. And it's entirely in Slovene currently. It's funded by the Tides Foundation, which is affiliated with Google. So we got a grant which funds the project, and the main goal is to introduce AI concepts to primary and secondary schools. So I understand that you are mostly from secondary and vocational schools, and I will focus in this presentation on these levels of education. But we also have lessons catered to primary schools. So the main idea of the project is to devise bite-sized lessons that introduce AI concepts, but that are based on existing curriculum. So, for example, I will use example from primary school. Children need to learn about the tree of animals. So, how to put animals into categories: mammals, amphibians, invertebrate, and so on. And we take this lesson, which is a biology lesson, and we present it with machine learning. So that's the idea: how to take existing topic in the curriculum and use AI to teach the topic. And in this case, we use classification trees, a very basic, intuitive, easy to visualize algorithm in machine learning to see the tree of animals, how they relate to one another. And we use Orange as the main tool to present this, this topic. In the past years, so currently I'm on maternity leave, so I wasn't involved so much in this project, but I started working on it just before I left, and we devised a couple of lessons. So here are the lessons that are catered to secondary schools. So this would all be taught at secondary level. The first is how to find non-conflicting bookings in a system, and this would be taught at informatics class. Then you can have how to teach climate belts in Europe, and this would be taught in geography. So you would have climate data, you would visualize it, explore it on a map, and use similarity, like clustering algorithms to find similarities between climate belts. Then you could also explore similarities of dialect groups. This is what we would teach at Slovene language class. An example that I will show you today is Monet versus Manet. So how to distinguish between two painters at art history. You could also teach similarities between NBA players at maths. So here, okay, NBA is not what you would teach at maths, but it is a fun data set that children would be, like pupils would be engaged with, but it introduces Pythagorean theorem, cosine distances, and so on. So things that you would teach at maths class. And finally, you could also teach oscillation at physics. Okay, so the example that I would like to introduce today is Monet versus Manet. So I was always confused who is who, like which are the paintings from Monet and which are Manet's, right? Because they lived at the same time and they have such a similar surname. So we would get the data from the internet, some paintings from Monet and some from Manet. And these would be all, of course, with a free license. So always be careful to get the data that's available for reuse. Then we would build classification workflow. So classification in machine learning is finding the patterns that would put the data into different categories. In our case, the categories would be Manet or Monet. So is the painting, does the painting belong into the Monet group or the Manet group? That's the basic idea. So at first we import images. So we load the data. Next, we would convert this data to numeric description so that a computer can understand it. Then we would train the model with logistic regression algorithm, and we would explore the model in confusion matrix, which tallies the score. So the correctly classified data, incorrectly classified data. And finally, we would inspect the model. So we would look at the data in each category. So this is what I'm showing here is the workflow, classification workflow for image classification. And each circle here is a widget in Orange data mining, and the data flows from left to right downstream. So this is how one such workflow would look like. And then we would inspect the results. So instead of showing this GIF, I would like to show you the software. Okay. Okay, so here you would have, can you see the screens? Okay, I will soon. Yeah, okay. Great. Okay, thanks. So here you would have the workflow. This is the canvas where you would stack the data. So you would stack the components one next to the other. So here you would load the images. So this is the data loading widget. You would import images. We have 107 images and 2 categories. The categories are Monet and Manet. Next, so the data flows downstream. So we connect the data import widget with data transformation widget. Here you have image embedding. This is some like machine learning concept. We take the images, we feed it to like a large model that converts it to numeric description. You can imagine that what this does is it assigns numbers to images, and it describes it, like how many circles there are, how many diagonals, how many colors. for example, this is not exactly what happens, but close enough, right? So this is what this widget does. Once we have numeric data, we would feed it to test and score. So this is the training procedure. The algorithm we're using is logistic regression. So we feed the algorithm, we feed the data to test and score, and then we train the model. Here you can observe the accuracies, but normally in these classes, we wouldn't go so much into detail. It's not about math and so on. It's more about concepts, right? So what's most important is this confusion matrix and then the image viewer. So this is what we would focus on in this class. Okay. There you go. So here I have confusion matrix. I have correct Manet images and what the model predicts. So the model predictions are at the top and correct labels are here. So if I click on Manet and Manet, so this blue square that says 46, I will see images that the model correctly guessed belong to Manet. Okay, so this is the correct classification of Manet images. And you can see what is typical of Manet. You can discuss that at art class, right? So Manet paints lots of people, has these muted colors and so on, right? You could, like, if you're an art teacher, you can talk about this. And similarly, here we have typical Monet, right? So actual Monet and predicted Monet, the 49 images. And here you can see already the difference. So Monet is a bit more like has impressionistic style, so a bit blurred images, lots of landscapes and water motifs. So something that you can mention as well. So with the help of this classification model, we can discuss, what's typical of a specific artist. And here then you would have actual Monet, but the model thinks these paintings belong to Monet, right? So this is the misclassified data. And if I click it, right, you can see that this is not so unexpected. So if we say, okay, Monet typically paints with muted colors and has people as motives, these misclassifications are actually paintings from Monet that are a bit more muted than his typical style and that feature people. So, okay, I mean, there is some point, right, why the model thinks this is Manet. And similarly, here you would have Manet. So the model thinks this is Monet, but actually it's Manet. And just like before, this would be Manet, in the style of Monet. By the way, these two painters were good friends, so it's unsurprising that that they had some similarities in their styles. Okay, so one feature of Orange is also this interactive data exploration. So when I click on a certain cell in confusion matrix, I immediately see the data in image viewers. So that's the idea in the classroom, right? So students can click and explore, and they can ask questions. So this interactivity is really at the core of our approach. Okay, so to wrap it up, where to go from here? So how can you get involved in such a project or have such a project of your own? The key thing is to understand machine learning and data mining concepts. So we use mostly classification and classification algorithms and clustering algorithms. So these two concepts are key to understand if you want to introduce machine learning to your class. For this to this end, we devised a series of YouTube videos that explain all these algorithms and approaches. and showcase it in Orange. So you can find it on YouTube, Orange Data Mining channel, and you can watch these videos. We also do teacher training. So with every class, we talk to the teacher, and we use a problem that they have, like a class, a topic that they have, and we try to introduce AI into it. So we develop each lesson with the help of the teacher. And finally, you can take existing lessons from our project, Pumice, and you can reuse and adapt them to your goals. Unfortunately, the website is currently in Slovene only, but if you're really interested, you can always reach out to us and we will help you go from there. So there's the project website, and you can write me. I will leave my email in the chat, and if you have any questions or you want to collaborate, feel free to reach out. Thank you very much.
So I think now we move on to the next presenter, Mr. Terence Tan. The floor is yours.
Hi, everyone. This is Terence. Really happy to see everyone here and share a bit about, how we at AdMaker and me personally as a teacher have used AI tools in our lessons. So my presentation is titled Demystifying AI for Students. And I chose this word very deliberately, demystifying, because often we are starting off with the assumption that AI is a very complex thing. And I think students can sometimes be a bit intimidated by AI and what it means and what it can do, cannot do. So we have tried different ways to introduce them to AI and get them to understand at a foundational level what it can do, what it can't do, how it works, and some of the limitations. So let me start. A little bit about me before we get started. Maybe it'll help to understand kind of my background as well. I used to be a school teacher in Singapore. So I've taught in elementary schools as well as high schools. I taught high school history and English, and I taught elementary school English. So that's my background. I've also worked in the Ministry of Education as a policymaker working on higher education policies. And I've also done some tutoring on the side. I ran my own tuition center for a while, and I'm currently in AdMaker. AdMaker does STEM and STEAM programming for students around the world, and we approach STEM and STEAM projects and programs through a maker education lens. So we get students to build hands-on projects, to look at using AI and other STEM tools to create their own projects instead of just mindlessly consuming what other people have done. So we think the best way to learn is by doing. And in the spirit of that, I will share how we've done so and maybe get everyone to do a little bit of hands-on later on. Yeah, I'll skip this slide. Basically, just sharing a bit more about AdMaker and our global reach. Okay, so this is the meat of it. I'm going to share about one of the projects that we do in schools called Junior AI Explorer. So the context is that we faced quite a bit of demand from schools' infocom clubs for CCA programs. So for our friends who are not from Singapore, this is a Singapore context, right? Each school has different, extracurricular clubs and activities. There is a club always that focuses on infocom technologies and, emerging tech, right? And some of these clubs are actually coming to us and saying that, okay, well, we know AI is a big thing. We want our students to be exposed. Can you develop a program that will help them do that? So we came up with a 9 or 10 week sequence where it's 9 or 10 weeks worth of lessons, right? Each lesson per week, but basically 9 or 10 sessions, right? Where we introduce students to AI and we introduce them to the AI project cycle, which I'll go through later. And by the end of that 9 or 10 sessions, the students have successfully created their own AI projects to solve certain issues or challenges that they see within their community. Today I'm going to dive deep on a couple of these sessions. I'm not going to go through all the sessions in detail, but give you guys a taster of how we've actually managed to do so, focusing on 3 different segments. The introduction, right, where I'll be going through the intro to some AI games to get students to start thinking about AI. Introducing the concept of the AI project cycle, right? Which I think, building on what my co-presenter shared earlier, AIDA, right, looks at how students can create their own AI models using simple software calibrated to their age range and comfort levels. And then I'll be sharing some student projects, examples of what students have done, screen recordings of what students have done for their own AI projects. Okay. All right. Taking the first step, right? So a lot of students, this is the first session. I'm going to set the scene in everyone's minds, right? First session, second session, students come in. They might not know what AI is at all, right? We've done this for elementary school students or, lower secondary students, 13 to 14-year-olds. And the first thing we try to do is to get them to think from the point of view of an AI. So I'm going to be sharing we use this game called Guess the Animal game. It's actually very, very rudimentary. Let me just quickly pop out of the screen and see how I can do this. There we go. All right, so I'm gonna play this as a student, right? But you guys can also play it on your own. Super flashy, right? And what you have to do is to press the button where you can guess the animal. So let's try to do that. You see the image will slowly appear, bit by bit, right? And at this point, some students will think that they know the answer, so they'll click. And a multiple choice pops up, right? A student will pick lion, right? And yay, it's correct. Now, let me just get out of here. Okay. So we use this game to showcase a couple of things, right? We use it to showcase how an AI actually thinks or works, right? How an AI actually behaves in a similar way by using the features that they see within the image to predict what animal it is. So we try to use questions to elicit that thought, right? I think as teachers, we know that questioning technique is very important in order to get students to understand a complex concept. So we started with simple questions like how many animals did you guess correctly? Very straightforward answers before diving a bit deeper and then getting them to think about how they managed to guess the animals correctly, right? And then what is the most number of tiles you have reviewed before guessing the animal? Why is it so hard to guess certain animals? Why is it easier to guess other animals, all right? But asking how they managed to guess it is a metacognitive question that gets them to think about, why is it that I click the button once those certain tiles appeared? Is it because I saw certain features, all right, within the image that prime me to think that, oh, it's a lion or it's another animal, right? These are some examples of what students responded, right? So we use Padlet, right? Because we were running this during the pandemic, but you can do so in your class, just question and answer. Some students will say, by looking at the color of their skin and their size, they use the color to guess, all right? But for the elephant, the color wasn't clear enough for me to see. That's how I got it wrong. So from this response, from Davina's response over here, we can bring out a couple of things, right? Number one, the students are able to guess based on the color that is shown, right? This is similar to how an AI makes guesses by looking at features and comparing the features of the image that is shown to those that the model was trained on, right? However, right, sometimes the AI gets it wrong, just like you get it wrong. If you are unable to see the color, the AI may sometimes also get it wrong if it misinterprets certain aspects of the feature, like Ida so elegantly put in the Manet versus Monet comparison, right? Sometimes there are false positives, sometimes there are false negatives, right? But my key takeaway here is that asking the follow-up questions are really important. Right? For example, what do you mean by the color? What do you compare the color of the image to? All right, getting them to think about comparing the color to your preconceived expectations or preconceived idea of what they should be seeing, right? Just as an AI makes predictions based on what it's trained on, we also make predictions based on our experiences and our things we've seen in our lives, right? So that's the kind of analogy we're trying to bring across here. And from the game, I think we want to consolidate, right? We want to consolidate students' understanding. So students will learn that AI requires data, firstly, all right? AI requires data, and in the game, you know, you see the animal, all right? You see aspects of the animal, and you use that data to evaluate what it should be. Secondly, the AI identifies image features, right? The AI identifies aspects like the lion's mane, or in this case, the fact that a squirrel is eating nuts. There's a grass in the background, there's brown fur. It tries to identify unique features of an image, just as you are also trying to identify unique features of the image when you're playing the game. And then lastly, but no less important, the AI predicts and classifies, all right? Just as an AI predicts a possible classification from the image features, you are also trying to predict and classify by predicting based on the features that are appearing on your screen, right? The pixels that are released. You're trying to assemble the pixels together to form recognizable features of the animal. But at the same time, AI can also predict wrongly. So humans can predict wrongly, and so can the AI sometimes. So this game is useful as an initial introduction to give an analogy. How we think is not that different from how AI also thinks. And this is a good first step for students to understand before we dive into the complexities. And obviously it's much more complex than this, but again, this is an introduction. So simplification is the goal. Then we can go a bit deeper. There are very popular computer vision games online. If we're not already familiar with Google, I think it's called Google for Experiments, or yeah, but Google released a series of very, very addictive AI games that can introduce students to AI using I guess they weave in AI elements into their game, right? So I'm going to give a quick example called Quick Draw. I believe some of you might have already heard of it, so I'm not going to spend too much time on it. I'm going to give you an example. Give me a moment to, here we go, right? So for Quick Draw, you have to draw a cat, right? And the AI model has to recognize it. So let's see if I'm definitely nowhere near Manet or Monet, but let's see, all right? Draw a cat.
I see circle, or blueberry, or apple. Oh, I know, it's cat.
Right. So the AI recognizes it and is able to draw a cat. So you can draw as many items as you want, and the AI model that's been trained on other people's drawings will try to recognize your drawing as well. It can be very addictive. But the key is not just to get students to play the games, right? It's also to ask them, how does the game work? Remember when I previously said asking about, right? Follow-up questions, ask how they managed to guess the animal correctly, right? In this case, it's the same. Asking the students, how does the game work? You know, and also just as important, understanding under what circumstances does the system not work and why. So I'm gonna just play a quick video where I screen capture the students' responses to our computer vision game, where we ask them, you know, how do you think it works, right? After you play the game, how do you think the system works? So we ask them a question, and you know, students have responses. You can see the responses over here, right? For this one, we asked them how many of you managed to, sorry, let me go to the right. How many of you managed to doodle within 5 strokes, right? What do you think will happen if we got an artist to draw the doodles? Do you think the AI will be better at recognizing it or less, not as good at recognizing? So we got quite interesting answers. Some students said, actually AI will not be better at recognizing because it's trained on people who are not artists. So the artist might try to overcomplicate things or bring a very impressionist or expressionist style that the AI isn't trained on. So you can tease out these responses and use it to probe, use it to facilitate a deeper conversation around how these AI models operate the games. Okay, so just giving an example of how we try to elicit student responses. So when we've actually introduced students to how AI works, then the next step is to, I want to share a little bit about why we focus on computer vision for the project, right? The games that I've mentioned just now are mostly computer vision games, right? And we did this because of a few reasons. I think everyone understands under AI, there's a few broad categories: computer vision, NLP, so on and so forth, right? So when we work with elementary school and lower secondary students, we normally focus on computer vision. Firstly, developmental appropriateness. It's easy to understand and it's very intuitive. There is student-friendly technology that lends itself very well to computer vision, machine learning for kids, teachable machine, range of social impact use cases. This will become obvious later on when I talk about how students create their own AI projects, right? And they use computer vision as a tool that lends itself very well to a range of social impact projects. And lastly, computer vision is not dependent on the language ability of students. That being said, if you are using AI to say in a language lesson, right, then using an NLP trained model might be more appropriate and more suitable for your use case. So now after they are comfortable with talking about how an AI works, right, then we introduce them to the concept of an AI project cycle. And so the AI project cycle that we use has 5 broad stages, okay? Define your problem, plan solution, collect data, train the model, and then develop the AI application. Sorry, I'm looking at the comments just to take a quick look and see if I'm missing anything out. CV refers to computer vision, right? So computer vision is a subset of AI, analogous to what the Monet and Manet example that Ida presented previously. You feed the model images, and the model is trying to differentiate between different categories of images. Previously, it was paintings done by Manet versus paintings done by Monet. In the case of Quick Draw, the AI is trying to differentiate between whether that image is a cat, a pond, what is it supposed to look like based on other people's drawings. The training data is other people's drawings. What else? There are other questions. Okay, so I think that's fine. I'll run through the different categories of the AI project cycle using a worked example to make it clearer on how we've done it with students. So we always, before the students embark on their own projects, we'll get them to do a worked example. Basically, this is a way to walk them through the whole project cycle before they do it by themselves on their own problem. So the problem statement that we give them, right, is preset at this stage, right? So back when COVID was a much bigger deal, maybe it's still somewhat of a big deal now, but back when COVID was a much bigger deal, a big problem for students and for teachers was that some students were not wearing their face masks in school. And obviously this is important because you want to limit the spread of the virus. So our problem for the students was, okay, well, students who do not wear their mask in school may cause risk to the people around them, right? So we want to stop this from happening. How can we use AI to make this happen? Okay, so we got students to plan their solution. Okay, what categories do you want your AI model to classify? Based on this example, right, what categories do you think would be appropriate, right? Maybe can anyone type in the chat? Does anyone want to give their thoughts? What categories would be a good example? What are the 2 different categories that you want to surface based on a project like this? Any thoughts? Based on you wanna assess whether the student is wearing a mask or not, right? In school. So your categories will have to be number 1, students who are not wearing a mask, and number 2, students who are wearing a mask, right? So those are the 2 different categories that you want your AI model to classify. Based on the input, you want to, the AI model has to distinguish between students who are wearing masks and students who are not wearing masks. Right? And in terms of data, what data do you need for this solution? You need data of people who are wearing masks as well as not wearing masks. You want trained data that features people both wearing as well as not wearing, right? And then how do you collect the data, right? Do you want it to take photos of people? Do you want it to do you want to search the internet, right, for samples of people who are wearing or are not wearing masks? So you have to plan out your solution before even starting to work on it. Then stage 3 is where you collect images of people who are masked up and not masked up, right? So in this stage, students will either take photos of themselves or their friends wearing masks or not wearing masks. They may also go online to search for people who are wearing masks or not wearing masks. So at this stage, normally we'll give them a set of guidelines, both for ethical reasons, right? We want to be ethical in the way we use data. So we'll tell them, for example, sometimes when people say, I don't want to use my data to be trained, you want to respect their decisions, right? So we remind them about ethics. And the second thing we remind them about is what constitutes a good trained image, right? If your trained image is on people wearing masks, you don't want to have a photo where you have everyone standing in the background. Some people are wearing masks and some people are not wearing masks, because that would be messy and that would confound the model, right? Especially when you're building a very simple model like this. You will then, after you've collected all the image, you will load into machine learning for kids, right, or teachable machine. Some of you may be familiar with it. Some of you know. I will give a very, very brief overview later on. But machine learning for kids online is a software, online browser-based software that can be used to train a model. It's drag and drop, click, no coding is needed. So it's very good for younger students. And after that, you'll train a model. I understand someone raised the hand. If you can type the question in the chat window, I'll come back to it when I have a milestone in the presentation. I do like to address questions as I'm moving along, so I can help to address it. Then the 4th stage, after you've collected all the image, you've loaded it into your model online, is to train the model, right? Train a model in machine learning for kids and to test it to determine what's the confidence percentage, and then to improve the model, right? In our sessions where we have more time, we can teach the students how to eliminate background interference, how to detect incorrect mask wearing. Like if your mask is all the way down here, can your model differentiate between that and someone who's wearing the mask correctly? Those are different ways that students can improve their model. Last but not least, they will download their model and build the app in Scratch, or they'll download as TensorFlow for use in different projects, right? If the student is familiar with text-based coding, they can actually download the software, download the code as TensorFlow, and they can use it in their own projects. So as a summary, this is the AI project cycle, right? And this is the different stages. And bear in mind, this whole sequence takes 9 to 10 weeks. So for those who are saying, how do we do this in one session? The answer is we don't. So this needs time, okay? And I know as teachers, time is what we don't have. But I mean, for better or for worse, is the trade-off we have to make, right? If we want students to get their hands dirty in creating real-life, relevant AI projects. Okay, so this is an example, the end result of the mask wearing model that we created just now. When this is my colleague, right? When someone appears without a mask, the AI will prompt it to say, wear your mask, right? When it detects someone who is not wearing the mask, it will say, well done. Okay, so this is the end result. Okay, the last thing I want to talk about, and maybe this is a good time for me to just pause a moment, check out my chat window and see if there are any questions. Save the, yes, correct. Okay, great question. Legal concerns about collecting image data of underage students. Safe to use the image of students. Teachable machine and machine learning for kids claim they do not store the data of their students. So you want to, this is a judgment call that sometimes teachers have to make. In our programs, we have recommended that students not use their own images and they collect images online. We suggest for students to use images in the public domain, right? But in some cases where schools have said, okay, well, I don't mind, my teachers have told us, well, as long as the photos are deleted off the laptops and off the system at the end, I don't mind students who use their own faces, right? The other caveat is, even if students want to use their own faces, that's a limited trained data that they can use. Maybe they can use their face, their peer's face, but in the end, you want to give the AI model a range of data to play with, right? For example, ethnicity is a thing, right? In Singapore, may have a class of, say, 70% Chinese ethnicity, right? That means my data is going to be trained on 70% Chinese ethnicity students, right? What if I introduce a Caucasian, what if I introduce a Caucasian image, right? Will the model be able to recognize it correctly as someone who's wearing a mask or not wearing a mask? So this is an interesting, important point to bring in elements of diversity, right, in trained data. But I think more to answer your question, that's a judgment call that students, that teachers and trainers have to make. Okay. When in doubt, I would not use images of your own students because there are a lot online that teachers can use. What students love to do, and I encourage, is for them to use images of celebrities, right? Because many images of celebrities are in the public domain, right? You have many celebrities who are wearing face masks and not wearing face masks. So that was a prime example that we used, right? So they spend a lot of time looking at their own celebrities, looking at their favorite celebrities. I have a question on, okay, I think that's CV games. Okay, most of the CV games that I mentioned just now are browser-based. You do not need to install any apps. So they work on a Chromebook, they work on a browser. Okay. I'm aware that time is running out, so I will jump back to finishing up my presentation and we can go back to questions later on. The last stage, right, is getting students to do their own student projects. And this is actually where we devote a bulk of the session. We devote a bulk of the training program to, right? Getting them to pick up their own student-run project, identify a project that's suitable for being addressed by AI, and getting them to go through the AI project cycle using their own problem statement that they have created. When we scope the student project, we like to use the Sustainable Development Goals and relate one of their problems to the Sustainable Development Goals, but you can use any other social impact framework that makes sense to you. I mentioned this previously just now, but we do have one session on AI ethics. I think this is important in getting them to understand how to use AI respectfully and responsibly. And that also helps them to scope their project, right? For example, some students may be interested in, I don't know, tracking their peers' activities online, right? To make sure that their peers are responsible and finish up their homework before they play games. But we have to come in and say, well, that may be an intrusion of their privacy, right? And that's something we don't want to touch, right? So AI ethics is important. a key point here is to give plenty of examples of how other people have come out with their own student projects, right? So we give students a range of examples based on what other students and their peers have done. So for example, how can AI, say, promote good health and well-being? We have seen projects where students are trying to differentiate between yoga poses that are accurate versus not done so well. So differentiate between the perfect downward dog and a downward dog that's a little bit sloppy, right? To encourage greater exercise and promote healthy living. Encourage recycling, right? How can AI, and I think there are many examples of this, how can AI differentiate between different recycling objects to better sort between a plastic bottle, a glass bottle, a paper cup, right? So that you can automate recycling, right? So all these examples are great because they give students an idea of what is possible, right? Sometimes students just don't know where to start. So it's important to give them an idea of where to start. So in the spirit of giving ideas, right, I'm going to give a few ideas, okay? So one group of students said that, we found that a lot of people had bad posture while sitting in the office or in class. For example, workers doing computer work while sitting and children while focusing in class. So I'm guilty of that. My posture is terrible. Okay, so I resonate a lot with this problem statement. So their solution was to create an AI application that is able to detect if you have bad posture or not. So the image over here that I have is a screen grab from the software Machine Learning for Kids, which is a browser-based software. So after the student actually puts in images of themselves with bad posture, as well as a good posture, then this is the data that the AI is trained on. You can see that they include trained data of students themselves, but their face is obscured. They include a range, right? Office workers, even like graphics, like cartoons or non-photographs, all right, of people having bad posture. We also tell them to take it from different angles, okay, because your input data might be from different angles as well. So that's what they're doing. And the same thing for good posture, right? This student made a mistake because he included the same data twice. So this is repetition, where we tell the students not to do. As a result, let's look at the example. This is the end result, and it's an AI app that's able to recognize posture by telling you, please sit up straight if you have a bad posture. And your posture is great. Okay. So these are examples. This is one example of a project. Other projects include this one, the model that detects whether you're touching your face or not, right? When you're touching your face, it says don't touch your face. Another model that detects which recycling bin your trash should go into. The second one over here, glass bottle versus plastic. And the last one, the model detects what emotion you're expressing. So one group of students say, I have students in my class who need help in recognizing emotions, right? This was quite a deep response, right? Even from secondary school students. So they want to create an app that can help their peers recognize how other people are feeling, right? So that's another example. Okay, I have a few more minutes left. So this is a bonus, okay? So I've covered a few things, right? I've covered how to introduce AI to your students, how to get them started on an AI project, right? And how to get them to develop their own AI projects. If you as teachers are interested in including AI in your own subject-specific lessons, meaning that, let's say if I'm an English teacher, I want to use AI within my English lesson, how can I do so? This is something that many teachers have struggled with, because when you're teaching AI in your class, you also want to be able to hit your content, right? You want to fulfill your scheme of work for the semester, because you don't want to waste precious curriculum time. So you want to kill two birds in one stone. And one way of doing so is we've developed a series of subject-specific lessons on a platform called AIED. So I'm going to give you an example of one of the lessons that's on the platform that might be useful. So this lesson is called Fraction Genius. All right, I'm going to spend a bit of time going to it right now. So this is the platform where I'll give, it's free to use, and all you need to do is sign up for an account. But what's great, what I love about it is that you can actually search, right? So let's say I want my students to learn about, and on this platform, all of the lessons are tech integrated. So they are integrated to not just AI, but other emerging technologies. But let's say I am interested in getting my students to learn about fractions, and I want them to learn about fractions related to AI over here, right? I'll search, and then there's a couple of lessons that pop up. Let's say I click on this one. So it'll introduce, I'm just going to go through the introduction. It'll introduce third grade learners to the fascinating world of fractions by training a machine to recognize fraction images. So we also include all the different resources like the teaching slides and all the worksheets. So let's say I click on the teaching slides. It's the slide deck that you need to use in your class, all right? And it incorporates a basic introduction to machine learning, right? And then it gets students to create a machine learning model, right? To differentiate between different types of fractions, right? We tell them to create different examples of 1 whole, 1/2, a third, 4th, 5th, 6th, and train your model to recognize different types of fractions. Okay. Don't have a lot of time to go through this in too much detail, but if you're interested, you can sign up for a free account on www.edforteachers.com. Check out this lesson, check out our other activities, try in your classes. Love to hear your feedback. Yeah, so this is the example that I've shown previously. This is a work example of how students could do it. One thing I love to ask students is, okay, what if you don't use a circle, you use a square, right? What if your image, your shape is different? How does that affect the accuracy of your model? Get them to think a bit deeper and think about a bit deeper about both AI as well as fractions. Okay, customization. So I think Ida mentioned about this just now. How do you use AI in your lessons, right? Any topic which involves classification or pattern recognition is perfect for an AI project. So you could customize the fraction lesson just now. So a topic for English would be, for example, like grammar, trying to get students to train an AI model to distinguish between past tense versus present tense, right? Or different parts of speech to differentiate an adjective from a verb, idiom from a metaphor. Grammar lends itself very well to AI because grammar is so, linguists like to put things in little categories, right? So if you need to teach grammar, then you can use this opportunity to introduce your students to AI. I think Ida already mentioned about taxonomy of living things, categorizing different animals like mammals, reptiles, amphibians, different art styles, right? Again, example that's mentioned by Ida. Humanities like landform types, right? For I have had peers who are geography teachers who use AI to get their students to differentiate between different types of volcanoes, different types of human environmental impacts, right? So these are just different ways that you can integrate AI into your lessons. Okay, so I'm done. Different ways to stay connected. Like I said just now, join AIED, sign up for a free account. We have 20+ lesson plans and more to come. It's our way of giving back to the teacher community that supported us so much in the past. So yeah, feel free to use those resources. We have a newsletter that we share practical edtech tips on AI as well as other emerging technologies. And feel free to connect with us over LinkedIn and Facebook, right? I'll share this set of slides later on. And the other thing I'm going to do is I'm going to just type in our Substack at maker.substack.com, where you can subscribe to our newsletter for, fortnightly, bi-weekly updates on edtech, usable tips on things to do in your classroom. Okay, I'm done. Yeah, just on time. Thank you so much for everything. I think I want to reiterate again how rare it is that we get teachers so passionate or interested in AI to take time out of your busy schedule to listen to us, and just want to say I really appreciated it.
Thank you. Wonderful, Terence. Thank you so much. From the chat box, as you can see, teachers, I think they found it really interesting, especially those who were teaching English. So today we have our intellectual partner for the whole project, Dr. Wayne Holmes from University College London here. So I'll invite him in a bit to ask some questions from the perspective of, in terms of building teachers' competencies, enhancing their pedagogical skills in terms of using some of the tools that both of you have mentioned. But before that, I saw that Ida was directly interacting with participants in the chat box. Thank you so much, Ida. That was lovely. Maybe you can summarize the insights very briefly, because I think some of the participants might not be paying attention to the chat box. So please.
Yes, thank you. So the question was, is Orange limited by the number of participants? And the answer is no, it's not. It's a software you download to your computer. So it has no limitation. It's just you download it and you use it on your own device. And it does not require internet. Some specific widgets do, because they rely on online models to speed up computation. But in general, you don't need internet, which is useful in areas that have unstable connection. So that's the benefit. It's not an online application. It's a tool that you download on your computer. And just a short, there was a mention of machine learning for kids. So what I saw as the main difference is that with Pumice project, we're not aiming to teach AI. We just use AI to teach actual classroom topics, and AI or machine learning is there just intuitively, by the way. So we don't focus on explaining AI, but we introduce it in the context of a specific lesson. So kind of intuitively, by the way. Yeah.
Thank you. Thank you, Ida. I don't see any more comments in the chat box. Wayne, the floor is yours.
And Ida, thank you so much. I really enjoyed both the presentations and learned a great deal. I've actually, Ida, I work with Earkai, and I was hoping to be trained by you, but then you had the audacity to actually go away and have a baby, which was outrageous. But it's really good to finally meet you, albeit virtually. I think, the work that you're both doing and the tools that you described and the approaches are amazing. And I think it's really very important stuff. But and there is always a but, of course there's a but. For me, I'm a social scientist, and what I'm really interested in is not just using and understanding the tools from a technical perspective, be it machine learning, be it coding, be it any of that stuff. While I think that's really critical for our young people to understand, for me, it's only half the story. And Terence, I noted in your 10-point plan or schedule, you did have ethics. I think it was week 5. So that means that you give 1/10 of your time to ethics. I'm assuming, approximately. I might have misread. Anyway, my point is this: that for me, I think it's really important that we always contextualize the teaching about AI in terms of how it's used and how it works and what it can do and what it can't do, all of which I agree is critical. But we need to contextualize all of that in terms of its impact on humans. And for me, the impact, the logic of ethics is part of that, but it's not all about ethics. It could range from the impact on jobs, impact on the kind of things and the ways in which we run our lives and what we accept as normal and what we don't. And of course, over the past few months, because of the launch of ChatGPT and all the other tools that have followed from that, there are, for me, lots of worrying conversations around the appearance that these tools actually understand what they're talking about or are intelligent in some way. And the reality that, as you guys know, these tools are not intelligent and they do not understand what they're dealing with. So a long preamble, but what I'm interested to know from both of you, if you wouldn't mind commenting, is how do you think those kind of issues, that broader set of issues, should be approached by teachers in classroom? And as you both said, when you're using AI to teach other subjects, but also when you're teaching about AI. So I'd be really grateful to hear what you think on that. And, obviously feel free to completely disagree with me.
Thanks.
Okay, so
Go ahead, Ida.
yeah, I will go first if you don't mind. So I absolutely agree that this is an important topic and it needs to be discussed. But I will just say we're specialists in machine learning. We don't pretend to be specialists in ethics, and we would hate to teach ethics without proper knowledge. So we teach what we know best, and we leave the ethics to experts in the field. And to be frank, we're still waiting for someone to go and either join us or have a similar project that would bring these topics to classrooms. At least in Slovenian context, I'm not familiar with that. So I would rather see someone with proper knowledge to tackle these topics rather than us trying to pretend to be specialists in the field.
That was a fantastic answer. And just so you're aware, we have been talking with Blaj, who is one of, I assume, is who Ida referred to as one of her bosses, about such a thing. So this is an ongoing conversation. I'm really pleased that you're open to it. And I agree with you. I can't teach machine learning, but I think it's that coming together of those two groups. And I think, it's the AI, because of its developments, particularly, the public developments over recent months, it's becoming increasingly important that young people understand, what they can trust, deep fakes and, fake news and all that kind of stuff as well. So I think this is really challenging. So yes, I value very much the idea of working together. And Terence, what do you think?
Yeah, I have a little bit of a different opinion. I think teachers sometimes might not have the luxury of deciding whether to bring something like this in when they are introducing AI, because sometimes students ask the damnedest things, right? Like they might ask something like, oh, can I use this photo, right? Which requires you to make a judgment call on the ground, whether they can use the photo because it's, it's in a public domain, or they can't because it's not a respectful thing to do. So sometimes as a teacher, reflecting, right, on my experience, I didn't really have the luxury of deciding that I want or don't want to bring in AI ethics. So we try to bring that into our training too when we are talking to teachers, when we're going through the program. That's why, as you mentioned, when we devoted one whole class to AI ethics, and we time it before they start planning their own AI projects, because we think it's so important to introduce them to something like this, right? We use the trolley problem, which is getting them to decide, right? We use the trolley problem example, and the example of autonomous vehicles deciding when to swerve, right? If you swerve, you're gonna hit someone, but you protect the driver, or you don't swerve and you may hurt the driver, get the driver in an accident, but you don't hit other people. So we try to introduce them to the idea that AI has to make those decisions, and there has to always be a human in the loop, all right, in order to check, to confirm that AI is making responsible decisions. The other thing that we always want to emphasize on, and I try to emphasize on, is foundational ideas of, like, and as teachers, we'll be familiar about this, foundational ideas of, respect, tolerance. How do you empathy, right? So if you don't want other people to use a photo of you in their model because it's embarrassing or shows yourself in an unflattering situation, you shouldn't do the same to others as well. So this idea of going back to SEL, right? What's a respectful thing to do? What's having empathy? Right, I think it's something that we try to bring into when we are getting students to think about how to use AI in a responsible manner. So we try to make those cross-curricular connections to SEL, to ethics, when it's opportune.
Again, a great answer. Thank you, Terence. I think it is the challenge we have is actually, I mean, those of, when I say we, I mean those of us on the who push the ethics and the human impact issues, is that often what we talk about is not as exciting as actually developing something. So it's an interesting state of play. You know, the big one in the US, AI for K-12, for example, again, they do talk about this, but again, it's a small part. So I agree with both of you that, you know, it's important that we do this, but how we do this, you know, we need input from teachers and we need input from ethicists to think about these questions more carefully. But for me, thank you very much, both of you. Really enjoyed your presentations and look forward to learning more.
Thank you, Wayne. Thank you for really asking some of the crucial questions so that all the participants, they can also critically reflect on it. That was really useful. So really, thank you. Terence, I see that there are some technical questions for you and you have already replied to them. Could you take a moment to kind of briefly summarize them for all the participants as well? I thought they were really important. Yeah.
Right. Let me see. We have a question on explaining math. So relating it to specific subjects, right? Relating the use of AI to specific subjects. I think that instead of giving suggestions of what topics to use AI on, which might not be super accurate because I'm not a math teacher, right? I am more comfortable in my humanities and languages domain. I would say any topic that lends itself to categorization is a good example for AI. And it's even better if the concepts or categories you're trying to teach are a little bit blurry so that their students always might make mistakes between categorization, all right? Because then you can use an AI example to tease out those differences, those edge cases, right? Or those fuzzy cases, right? So for example, in English, like grammar is something that is categorized, but students always get confused because they're edge cases, right? Does E come before I, but after C? I mean, all those issues with language, grammar, things like that. So I would say, yeah, that's one way to see it, right? Looking at concepts which lend themselves to categorization, and students get confused by those categorizations. Those are good topics to use to bring in AI. That's one of the responses. Then I think someone said it's Maria. Maria from Portugal mentioned, is it feasible to build an application using AI to weigh the separated waste as part of a contest to promote recycling? I have an example, right? But that's based on categorizing different types of waste. I just want to clarify, does this question refer to using an AI to weigh how heavy each group of recycling objects are, or is it about using AI to differentiate the type of recycling? You can reply to my message later, because as I'm reading, I'm realizing that the example that we have is about recycling classification, not so much on using AI to weigh it. Yeah.
You don't need AI to weigh it. You just need a scale.
The weighing scale, or maybe AI to help. Well, I don't know. Yeah, but we don't have one. Yeah, I think that's pretty much it, Jyoti.
Thank you. We have, I see Mr. Uddin from Bangladesh raised hand. Please, the floor is yours. Feel free to ask your question.
Hello, can you hear me? Hello.
Yes, we can hear you.
Okay, thank you very much for our brilliant speaker. I really enjoyed the lectures and I really learned a lot of things from this self-learning phases. For our brilliant speakers, Dr. Wayne Holmes, Marcus Pedaste, and our brilliant speaker, Mr. Terence, and as the questioner. So my question is it necessary to use AI tools in our classroom, in every classes, if we want to make our class fruitful? Because we notice that sometimes our students misuse technologies, and sometimes we see that if all time our students or learners depends on AI tools or technologies, they would lose their mobility to think critically, and they lost their creativity. So my question is it necessary to use AI tools all time or in all classes to fulfill our classroom? Thank you very much.
Thank you, Uddin. Who'd like to take it? Ida or Terence, please feel free to respond.
I can take this. Oh, Ida, you want to go first?
Go ahead, go ahead.
Yeah, I guess my answer is pretty short. My answer is no. It's not. I would not recommend it using it for all lessons. I think AI is useful to hook students and engage them. But I think we have to be very clear about which lessons lend themselves better to AI and which lessons don't. In terms of the machine learning examples I mentioned, like I said, I want to go back again to how do we identify lessons or concepts that are suitable for machine learning projects, right? Categorization, fuzzy categories. I mean, there are a whole other bucket of language lessons that you can use ChatGPT to kind of, come up with your essay drafts and all that, but that's outside of our scope of this session. That's more of a prompt engineering, right?
Thank you very much.
Ida?
Yeah, I completely agree with Terence. Just find a topic that resonates with you and where you think AI would work best. Especially, I mean, it's important for me to stress. It's not about using AI to do the work for you. It's just to help you organize the data and think about the data. That's key. You know, AI. I won't say AI. Okay, this is misused like continually. Machine learning can help you organize the data and find patterns. But then it's up to you to think, what does it mean? Where does this pattern come from? Is it real or is it artificial? How can I put this back in the context of the data? So this is what students have to do, right? This is the task of the students. They have to think like, what do these results mean? So use AI or machine learning for tasks like this, right?
Thank you. I see a couple of hands raised as well. Tito Felipe from Portugal, then Baklan Kuhamet. Yeah, please, Tito.
Okay, hello to all. Many thanks for what you have said to us today. It was great to understand how the concepts and how everything function. I think it's very important for students to understand how machine learning works so they can understand how responses are constructed. And I think it's the first base before we try to explain how artificial intelligence works. I think it's very important to make them work with samples to think as a machine, because if we use that, it's important to them to think how the results will appear. It's very important, and many thanks to Aja. I don't see everything because I have problems to enter on the session, but I will start from the beginning to understand everything, and thank you for your ad. Thank you to all.
Any comments from you, Ida and Terence? Yeah, Terence, sorry, go ahead.
So sorry, I wasn't sure what the question was.
Is an affirmation about what you have. I agree with you. It's important to understand how machine learning works for the students. It's the question. I think to work with that, we can construct hunting games to make the students to understand how that work. I have seen your examples, and the samples are very good to work with that.
Thank you, thank you. Yeah, I think it's important for them to understand how it works before they dive into doing their own projects, right? If they don't understand how it works, then their project that they make might have issues, might be faulty, they might run afoul of ethical. So I think getting them to understand at a conceptual level how AI works is important before we dive any deeper into, which is why the first game that I shared doesn't involve AI at all. It's Guess the Animal. It's not AI at all. It's just introducing them to how we think and then relating it to how an AI also makes decisions. Yeah.
Thank you, Terence. Ida?
I would just agree. Yeah, I mean,
Yeah. So we can take one more questions, and that's from Baglan. He raised his hand earlier, and then there is a yeah. Sorry.
So listening to your session, yep. So teachers should use. Do you hear me?
Yes.
Do you hear me? Okay. So yeah, we teachers, as any teacher, English teacher, the math teacher, everyone. Yeah, we have to employ the AI tools for feedback, for arranging, for data, everything. So I want to ask, how should we balance this AI instrument in our texts, and then our students kind of they are sponges, they absorb everything, and then they will put it back when they are writing or speaking to you, and then sometimes you could not identify whether it is the human written or the AI generated one. So how should modern teachers balance these AI tools in our teaching skills or in our teaching performance? That's all my question. So how should we balance these AI instruments in our teaching performance?
Can I clarify, when you say balance, what do you mean by balance? Is it balance between use of AI versus traditional teaching, traditional methods of instruction?
Yeah, we are kind of using the, for example, for analysis AI, for generation AI, we are using AI tools. We for formulating the AI tools, also for the constructing even the lesson plans. Yeah, so every time I say to ChatGPT, yeah, today I'm going to teach to my students this topic, for example, the human or the environment issues, and then please make up the lesson outline, and then it will make up lesson outline, and then I start to make some videos, and then some audios, also everything are generated by the AI, and then even my feedback is going to be as the AI tools. Yeah, so and when I gave them the AI generated text, they start to absorb, my students start to absorb everything. So I want to balance to what extent should I use these AI tools, that's all. So that I could have not the AI generated, but the natural human speech.
I think Baglan is trying to approach the human dimension of, in terms of cognitive ability.
Yes, because we are not doing any analysis anymore, because everything is ChatGPT is doing, Humata is doing. So there are lots of AI tools that are helping us, but in the other side of the bridge, yeah, we don't have that ability to analyze, to synthesize, to function some kind of the human activities, yeah, that the brain can do. So how should we balance it? I'm asking for that question.
I have a comment related to that, but I'll allow our speakers to first comment. Please go ahead. Maybe Ida and then Terence, because I see Ida.
yeah, I think that's so. I think that's it's every teacher's discretion. We're not dealing with AI generated models. Like, we're not dealing with generated models in our project. We're dealing with machine learning. That's just data analysis. So I have no specific opinion on AI generated content in teacher in a classroom setting. But I mean, this is really not my expertise, so I will just retract myself from this. But I think it's up to you, and you always, have to nourish the critical thinking skills. I mean, from my perspective, ChatGPT did not do a very good job in assisting me to write. So, yeah.
Terence? You are on mute.
Yeah, sorry, I have a bit of issues with my Zoom. Yeah, so I think this is a question that we have had to think long and hard about, right? A few thoughts. Firstly, the AI can make mistakes, right? And then when it makes mistakes, these are prime teachable moments, right? I mean, as teachers, we always used to use the phrase teachable moments when you don't plan for something to be, you don't plan for a lesson to be learned, but it's a prime opportunity to seize on at the moment to try to impart a lesson. So the teachable moments happen when the AI makes a mistake, and then you can use it as an opportunity to facilitate a discussion. Why does it make a mistake? Would it look any different if there was a human in the loop? Why would it look different if there's a human in the loop? You can also use real world examples of how AI makes mistakes, right? I think many examples now in the news can be used to balance out the assumption or the preconceived notion that AI is like the solution to everything. More relevant to our project, right? When the students are building their own AI projects, the AI project can make mistakes too, right? It may be detecting a great example is when we're using the face mask example, race or ethnicity comes into play sometimes, into affecting how the model is designed. So that's the conversation that has to be handled sensitively, but it's also a good opportunity for us to bring in concepts of, okay, why does there have to be a human in the loop? Because you don't want racial profiling in your AI, right? That has happened in the past. So I think all these issues about ethics and everything that we've talked about before will be woven in to kind of like balance it out. Yeah.
Thanks, Terence. First of all, I like Ida, how you wanted to kind of stay away from it, saying, it's not, this is not, you will stay away from commenting on that, but you already gave in a way, I think, recommendation to say, you decide, right? So for Backland's reference, if you remember when we did the first welcome session with all of you, we had our Executive Director, Ambassador Toru Morikawa, as the speaker who gave you 3 key insights. And both of his parents are actually teachers. So his perspective are actually very teacher-centered. And he said that as teachers and educators, you take ownership of any type of AI innovation that takes place in your own classroom, which is why it's really crucial that you understand what AI is and what AI is not, which Wayne, our first speaker, actually very clearly laid out during his presentation. So I think what I'm trying to say is that you need to be critical and you need to take ownership of the way you want to teach in your classroom and the way you want to empower yourself as well as empower your students. So that would be my comment. I see a couple of comments that I haven't had a chance to read, but I think, I like what Jingjing Liu from China mentioned. I think teachers are the ones who knows the students best. So it is teachers who should make teaching plans or things like AI tool. AI tools are just assistants. Yes, I agree. They are just supposed to be, I think, supporting teachers, but not necessarily replace or be instrumental before teachers. What else? Okay, from Wayne, he agrees with Terence, but he thinks that it should be humans in control. Yeah, exactly. I think what I was just talking about, referring to the welcome speech we had. Yes, absolutely. Humans should be in control and computer in the loop. I like that. Okay, thanks, Anna. Yeah, it's actually not my comment. It's coming from Toru, our executive director. So thank you for your kind words. So we are almost, actually, we were running over by 1 minute. So I would say we did a very good job with 2 speakers, and Terence and Ida, you did such a wonderful presentation. And I think from your presentation today, we had such a lovely and critical discussions. And thank you so much to you participants as well, because without your active and interactive participation, we cannot have this session today. So thank you so much for making time to join the session live. And thanks, Wayne, also for jumping in and asking some of the questions that are really crucial. And with that, I'm going to share my slide to tell you about what to expect next. But before that, we let our speakers go. Ida and Terence, thank you so much again. And we absolutely love to work with you further for this project. Thank you.
Thank you.
Those of you who are our self-learning phase participants, congratulations, you have successfully completed the program. We will get in touch with you through emails regarding, certificates and other specs. So congratulations to all of you. And the full program participants, those of you from the school collaboration who are joining us for the self-learning, team learning, and action learning phase, your first peer-to-peer session begins. So the team learning session begins next week. We will be sending you relevant details in an email soon. And for those of you who are joining for the faculty collaboration project, the cross-faculty dialogue phase begins. We have already sent out relevant information through email. So please, if you haven't checked our emails yet, please do check the program as well. And with that, thank you so much. Thank you again for